Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone to try this question and write your answer in the comment box. I believe you have tried, so let's start. Now what is the best reason for this conversion, or technically if I say epoxidation? Okay, see, this epoxidation is actually oxidation where this alkene is oxidized to corresponding this 3-member cyclic ether named as epoxide. So here 4 reagents are given. Which one is the best? Before going to the details, look at this molecule, student. This is actually an alpha beta unsaturated carbonyl. They are also called as Michael acceptor. By the way, I have already discussed a dedicated lecture on this molecule. You may visit for further learning. So what you can expect in this molecule? So this molecule can undergo a resonance. So it can go there and it can open. So what does it will produce? So there is a positive charge here, this is, and this is O minus. So what message this resonance gives us? That this carbon is actually a electron deficient carbon, or technically if you can say it is a electrophile. So a electron rich molecule or nucleophile can attack this. So this reaction is nothing but nucleophilic epoxidation. So how can I generate a nucleophile? Whether if you look at hydrogen peroxide, it has a significant nucleophilicity. Why? So if you look at these two oxygen atom, each one has 2 lone pairs, and because of this adjacent lone pair repulsion, which is technically called as alpha effect, the energy of the HOMO of this molecule raises. Not only that, these molecule can undergo reaction with, I can say, KOH. Okay, so it will react with this KOH, and what it will produce? It is called peroxide anion, hydroperoxide anion. So O minus H, and obviously along with water. By the way, this molecule also has alpha effect, and you can see it is also very reactive, and actually it's a very good nucleophile. So what it does? So this molecule goes and attack here. It will open up, and what is the product? Because of this, it will produce these peroxide. So one side is OH, another side you can expect this is a R. Now next, peroxides are not that much stable. Because this repulsion, they are prone to breakdown. So how the next step happen? So this lone pair pushes it, this electron density attacks here, and this breaks. Now if I say technically how it's happening, so these electron pair on this carbon, I mean the negative charge, gives the electron density to the sigma star of oxygen bond. So how a single bond is break? Actually here the negative charge or electron density is given to the sigma star, bond order becomes 0, and in this way this bond breaks. Consequently it results in an epoxide, and obviously the remaining part is this one. So in this way the epoxidation takes place. Now what is the reagent? Answer obviously this one. Now if you say why not this sulfuric acid? By the way, sulfuric acid is acidic. It will not allow the hydrogen peroxide to deprotonate. Now it will protonate the hydrogen peroxide. So if hydrogen peroxide gets protonated, look at here, positive charge. So means electron deficiency, so that lone pair repulsion to some extent stabilized. So that's why it will not react. And by the way, if you look at how hydrogen peroxide stores, hydrogen peroxide is a very reactive molecule. If you want to store it, you can add small amount of acid, which hinders or act as a negative catalyst for the decomposition of hydrogen peroxide. Means this acid stabilizes this molecule, resulting it decreases the reactivity. Second, here this m-CPBA, meta-Chloroperoxybenzoic acid. By the way, I have already discussed a dedicated lecture on this also, so you may visit. Now on MCQ, so it's m-CPBA. It also has a peroxy linkage, so you can expect such same kind of reaction can take place. Yes, but it is not that much reactive because there is an electron withdrawing group here which stabilizes the one lone pair to some extent. Point number 1. Second, this m-CPBA in DCM is actually a electrophilic epoxidation reagent. But I have already discussed another dedicated video on this also. Okay, but what I need here, nucleophilic epoxidation. So in this case, this double bond case, it is not a proper choice. But if you take a simple double bond or electron rich double bond, that time this m-CPBA is a good candidate. And what about KMnO4? KMnO4 oxidizes this double bond to cis-diol, not epoxide. So this is not at all an option. So this is a very interesting MCQ. Lots of knowledge I guess you got. So in this case, by the way, this m-CPBA in DCM could be a better epoxidizing agent if you take it in KOH, not in DCM, if you take in aqueous KOH. So remember, this is another information that if m-CPBA is taken in aqueous KOH, then this deprotonation takes place, it produces this anion, then it can act as a good nucleophile and perform the nucleophilic epoxidation. So this is the overall discussion. Now if you get this question in your exam, look at what kind of reagents are given, what is their behavior. So in this case, I suggest you should study as much as you can. So hydrogen peroxide alkali is the best combination for electron deficient alkene epoxidation reaction. So this is the overall discussion. I believe this video may be useful. By the way, student, please do not get confused about the logo of my channel. This is swastika. It is not hooked cross. This swastika is far old compared to Hitler's time, this hooked cross. It is a holy sacred sign, sign of peace, you may consider, not a sign of brutality like hooked cross. So do not get misunderstood. I believe that you'll understand, and by the way, I never support any kind of brutality or Nazism. So this is the overall discussion. Thanks for watching. See you in the next video. Bye bye.